This is example 4 based on binomial theorem. We have to use binomial theorem and to prove that 6 raised to the power n minus 5n always leaves a remainder 1 when divided by 25. Right. So we'll be using this theorem, that is the binomial theorem expansion, for solving these questions. Right. So let's say if I have to prove this part being it is divisible, it will leave remainder 1 divided by 25. It means we have to prove it as this number, this is equal to 25 times any positive integer plus 1. That is what we have to prove. Let's see how we can do it. So first of all, I'll split 6, right? 6 I'll write in terms of this, so we can apply this binomial, right? Let me write on the question. This is 6 raised to the power n over 5 and copied. I can write 6 raised to the power n as 1 plus 5 raised to the power n, keeping minus 5n as it is. Now I'll be applying this binomial theorem here at this one. So what we can see here, that we'll apply, on applying, we'll get NC0 plus, next is NC1, right, from here, NC1, that is into 5 plus NC2, 5 raised to the power 2, plus NC3, 5 raised to the power 3, plus NC4, 5 raised to the power 4, so on. And finally, it is NCN, 5 raised to the power 5. 5 raised to the power n, n being the last term. And then it's minus 5n at the end. That's not a part of the expansion. Now, what we can do, I can write NC0 as 1, and this NC1 is 5. So 5 into n is 5n. Plus 5 square, that is 25, or you may simply write 5 square. This is 5 square, NC2 plus 5 raised to the power 3, NC3 plus 5 raised to the power 4, NC4, and then 5 raised to the power n, NCN minus 5n. As you can see that there are two like terms here, so these can be cancelled. That is 5 raised to the power n and minus 5 raised to, that's 5n and minus 5n get cancelled here. Now writing this part first, I'm writing this part. From here I'm taking what is coming common as 5 square is common. So I'm writing 5 square common. So what do we get inside? I'm taking 5 square as common. We'll get NC2 plus, if I take 5 square common here, I'll get 5 NC3. If I take 5 square common from here, I'll get 5 square NC4, and so on. Taking 5 square common from here, I'll get 5 raised to the power 2 power less NCN. And this plus 1, and I can write at the end. As you can see that whenever we do expansion of this binomial, it has to be a positive integers where when n is positive. So I can write this as this being 5 square. 5 square is 25, and this I'm taking it as k, like from here till here, it is k plus 1. So this proves that 6 raised to the power n, 6 raised to the power n raised to the power n minus 5n is represented like this, right? So we prove that this is leaving a remainder, this expression leaving a remainder 1 when divided by 25.